Hello everyone, we are presenting our AI final project Tic-Tac-Toe implementing using multi-agents. This is me Roshan Reddy Mumadi and my teammate Adla Varshita. Tic-Tac-Toe is a simple two-player game where opponents take turns marking spaces in 3x3 grid. The goal is to get 3 of your marks in a row horizontally, vertically or diagonally before your opponent does. Coming to objectives, it mainly focuses on 3 AI agents for Tic-Tac-Toe: Q-learning, min-max and alpha-beta pruning. Q-learning adapts through reinforcement learning. Min-max uses adversarial search, and alpha-beta pruning optimizes minimax. Agents compete in multiple tic-tac-toe games, earning points for 3 consecutive symbols, performance metrics, including winning rates, execution times, and exploration efficiency. These all will be compared to determine which approach, either reinforcement learning or adversarial search, proves more effective in tic-tac-toe. Coming to approaches, our first approach employs Q-learning from reinforcement learning, while the second utilizes adversarial search with min-max and alpha-beta pruning. The technology stack involves Python. Coming to deliverables, explore our user-friendly documentation for tic-tac-toe with min-max, alpha-beta and reinforcement learning agents in Python. Access the complete implementation on our GitHub and visualize the project through our YouTube video with insightful slides. Coming to evaluation methodology, our project assesses AI agents in one-on-one tic-tac-toe matches, calculating wins to determine efficiency. A detailed comparison table and graphs highlight moves, scores, win rates, and time space complexity for Q-learning, min-max, and alpha-beta agents. From now on, my teammate will continue.
Hello everyone, I'm Edla Varshita. In this tic-tac-toe game, we are using 3 algorithms: minimax algorithm, alpha beta pruning and Q-learning. First, we are installing the tree library. From that, we are importing the node and tree libraries. Firstly, here we are creating a Python class to store the state, and it allows update to the board, check if the game is done, and return the value of our game depending on the outcome. Next, we recursively create the gain tree and add the board state object at each node, and the idea of the each node is the sequence of the steps taken. Here we are preventing changing these values in order branches of the tree. At the end of the game, we will stop adding the nodes. Next, with the tree done, we can use minimax code very similar to the simple tree we first started with. Using determine move, we can now get the next best move. Note that in case multiple moves have the same max value, we choose a random move here amongst those max moves. For example, when the max player plays the a square game. Next, here we are having the evaluate function. It is nothing but a heuristic evaluate of state. There are param state, the state of the it is nothing but the state of the current board, and here we are returning the +1 if the computer wins, or the -1 if the human wins, or 0. The function test is a specific player wins. There are 3 possibilities: 3 rows, 3 columns and 2 diagonals, and there are 2 notations, that is X and O. Next, we are using the alpha beta pruning. Alpha beta pruning is it represents the best score that the maximizing score can guarantee at or above the current level. Beta represents the best score that the minimizing can guarantee at or above the current level. The algorithm maintains alpha and beta values throughout the search. And there are some rules. If the score of a node is worse than the current alpha value, then the maximizing player would never choose this node because there is already a better choice. And the next is Q-learning. Q-learning is a reinforcement learning algorithm. The goal of the Q-learning is to enable an agent to learn the optimal strategy by interacting with an environment, receiving feedback in the form of rewards and updating its knowledge over time. So that's all about the project.